and welcome to my Mathematical World 3. I found something online the other day called Vedic maths, or a little tiny bit of Vedic maths, which I thought was rather fun, and I'm going to share it with you. But it actually raises a completely different question, and something that I think it illustrates very well, which is, and don't get frightened, why algebra is so much clearer and, to be honest, cooler than arithmetic. We'll come back to that. Let's have a bit of fun with some numbers first. I'm going to try and remember to do everything I need to do. First, I'm going to share my application, which is coming off my iPad, and I hope that you can see that. So, Vedic maths, why algebra is cool. If you don't know what Vedic maths is, there's a very long and enormously distinguished tradition of mathematics in India, and Vedic maths tends to be a name that's given to some of the, shall we say, slightly more unusual ways in which they approach the wonderful subject of mathematics. So let's first of all do this little piece of mathematics or arithmetic and see what's going on, and then we'll have a look at how to do the same thing but using algebra. And I'm going to do something that might look absolutely pointless. Let's start by saying, let's suppose we want to multiply two numbers together, and we'll take 14 and we'll take, I don't know, let's say 7. Now, I'm going to pick a number that's reasonably convenient. So I'm going to pick a number 10, which is fairly close to both the numbers that I want to multiply. And I'm going to do a couple of things first of all with them. The first thing I'm going to do is to subtract 10 from both my numbers. So I'm going to subtract 10 from 14, which obviously gives me 4. And I'm going to subtract 10 from 7. Notice I must do it in the same order. Subtract 10 from 7, and I get minus 3, or negative 3, as it really should be called. So far, so good. Then, and you'll see why in a moment, I'm going to multiply these two numbers together, the minus 3 and the 4. And minus 3 multiplied by 4 is minus or negative 12. I'm sure everybody can see that. Right, now we're going to start doing something a little bit different. Let's change the color. I'm going to do a bit of addition. I'm going to do 14, and I'm going to add the negative 3 that I've got underneath it, and you'll notice that that gives me 11. I'm going to take the 7 and I'm going to add the 4 that's underneath it, and I'm sure you can see that that gives me 11 too. And this, in fact, always works. And one of the things I want to show you using algebra in a moment is, why does it always work? Why do you always get the same answer? May not be obvious, perhaps it is obvious. But we'll put the 11 numbers always the same in the middle. And now we'll do this multiplication, 10 multiplied by 11. And what does that come to? Well, 10 multiplied by 11 comes to 110. And then we'll say, but 110 minus 12, in other words, adding together these two numbers, comes to 98. And 98 is, of course, what 14 multiplied by 7 is equal to. Wow, isn't that interesting? Does it always work? Yes, it always works. And contrary to what impression you might get from looking at some of the videos you can see online about this, the number 10 in the middle is completely arbitrary. It's just a nice, easy number to multiply by. Okay, let's do one more example very quickly, and then we'll see another one. Let's do it with some slightly bigger numbers. What shall we take? Let's take 21 multiplied by 18. Something that's not quite so easy to do in one's head. And this time, just to prove that it doesn't matter what number you take, let's take 20 as the number that's close to both of them. Then we'll do our subtraction. 21 take away 20 is obviously 1. 18 take away 20 is minus 2. Yes? Do the multiplication in the middle, and that gives us minus 2, negative 2. Do our addition. 21 minus 2 is 19. 18 plus 1 is 19. Wow, it works again. So we get the same number. And 19 times 20, well, you can probably see that 19 times 2 is 38, multiplied by 10, 380. 380 minus 2 is 378. And if you just look at this, you can probably see that 20 times 18 would give us 360, plus 18, 378. So it works again. Question is, why does it work? Well, let's have a look at it if we're going to do it using letters. Suppose we want to multiply A by B, where A and B are any numbers at all. And let's choose as the number that we put in the middle just n, where n can be anything at all. Then we do our subtraction. A minus n, well, we just write the letters down. In fact, it's easier because we don't need to do any work at all. We just write down what we've got. B minus n is b minus n. Easier than the arithmetic, no work involved at all. Right, if we multiply these together, we get a minus n multiplied by b minus n. We'll come back to that in a moment. Now let's do our addition. When we add the number at the top to this, we get a plus b minus n. When we add the number at the top to this, if we slot the b in the middle, we also get a plus b minus n. So lo and behold, we've actually got a proof here of the fact that this method will always give us the same answer. So what we're going to end up with here is always going to be a plus b minus n. And when we do the multiplication, we will get n times a plus b minus n. How does this help? Well, we're going to need a little bit more space, so let's go on to a new page. Remember, what we do next, and we've done it twice now with numbers, is we add together these two expressions. What do we get if we do? Well, we need to work out what they are. So let's write them down on a separate page. This is a minus n times b minus n. A minus n multiplied by b minus n. Well, what does it come to? It comes to a times b from that term minus an from that term, minus bn from that term, and then minus n times minus n plus n squared from that term. So it comes to AB minus, and you can see that there's a factor of n that comes out of this. Look at the way this works. I've taken out minus n, so minus n leaves me with plus n, so that term there gives me this. That term there gives me this, and those terms there give me this. But let's just go back. Hold on a minute. What was my blue expression down here? Oh, it's just the expression that I had on the next page, the plus n times a plus b minus n. So remember, what we did was we added those two expressions together to get what was in the corner. So if we go back and add these two together, what do we get? Well, the AB is left all on its own, and every term here cancels out. So we're just left with AB as our answer. But of course, AB is exactly what A times B is equal to. So the Vedic method is really just a hidden version of a little piece of algebra, which involves a certain sequence of multiplications, the vast majority of which cancel one another out to leave us with the answer that we want. Let's do it just once more for fun. Let's take 107 and multiply by, let's choose something really ambitious, 86. And I think the obvious number to choose is 100. So we do our subtraction and we get 7. We do our subtraction, we get minus 14. When we do our addition, we get 93. When we do our addition, we get 93. When we put our 93 in for our multiplication, we get 9,300. And when we do, I left the multiplication sign out, our 7 times minus 14, well, as it happens, purely coincidentally, that gives us minus 98. Remember, that's actually the very first calculation that we did, 14 times 7. Believe me, I'd love to pretend I planned it this way, but it's just turned out like that. So when we look at our method, we've got to take 98 away from 9,300, so we get 9,202. And if you would like to check it out, I'm sure that you'll find that 107 times 86 does indeed come to 9,202. I think the Vedic maths is lovely. It's probably not terribly useful, not certainly in a day over the calculator, but it was invented, of course, at a time when nothing was available except the power of one's own mind and whatever one could write with. But I do think that showing it to illustrate how algebra works, and indeed how much clearer the algebra is, providing us effectively with a proof of the method, is a lovely little illustration of one of the wonderful ways that algebra can help us, even in very simple arithmetic, to see what's going on. Thank you for listening.